Hello, everyone, and welcome to this complimentary Wood Mackenzie webinar. Today's webinar is a part of a series of webinars that we do throughout the year to help keep professionals in the power and renewables market stay informed through research and analysis on the latest technologies and market trends. Today's presentation, Managing Utility Solar Risks, Selecting the Right Foundation for the Right Site, is brought to you by TerraSmart. I'm Sagar Chopra, a research analyst at Wood Mackenzie, and I will be moderating today's webinar. Before we get started, I'd like to take a moment to go over the screen in front of you. Speaker bios are accessible from the top tabs by clicking on each speaker's name. Most importantly, please note the Q&A module on the left side of your screen. At any time during today's presentation, you can submit your questions for our speakers. I believe we'll have about 5 or 10 minutes of question and answers after the presentation. We will be following up with an email to send a copy of the slide as well as the case study that will be presented by the team at TerraSmart on today's webinar. And with that, let's get started. I just wanted to give a quick overview about TerraSmart, which is the renewable energy portfolio of Gibraltar, they're a leading provider of solar racking technologies, electrical balance of system products, installation services, and project optimization software. TerraSmart also recently announced their brand new launch in early November, which united 4 solar legacy brands, RBI Solar, Sunfig, Solar Boss, and the former TerraSmart. Serving the commercial and utility sectors across North America, the new TerraSmart integrates products and solutions across the PV life cycle to minimize risks and maximize returns. With over 19 gigawatts of solar deployed across 4,600 PV systems, TerraSmart creates a unique value for more profitable solar on any terrain. To start things off, I wanted to give a brief overview of the global fixed tilt and tracker market. Fixed tilt continues to remain the dominant technology, as not all projects justify a tracker system, but we do see that in the next the tracker adoption has been gaining traction, and the next couple of years it is expected to inch towards almost that 50% mark of total global installations. Not sure what happened to text here, but in any case, the presentation will be sent to everyone after the webinar, and I'll make sure the font size is correct on that one. But on this slide, I just wanted to talk about some of the challenges that the PV industry has been facing and how some technological improvements have helped to offset these headwinds. COVID-19 impacts, we all know, the world was affected by the COVID-19. I just wanted to go over the challenges that the industry is facing in 2019. We all know that the world was affected by the COVID-19 in 2020, but the effects were more pronounced throughout the industry in 2021. Steel, which makes up a major part of the raw material cost in fixed tilt and tracker systems, has been rising steadily since the start of the year and is now at 2 times to 3 times across different metal indexes. Chip shortages is another headwind that the manufacturers are facing as tracker controllers compete with consumer goods to secure supply from chip manufacturers. Freight costs that have become 3 to 4 times higher than the pre-pandemic levels have also created a bottleneck for the entire PV industry and is adding to the lead times. Having said that, the innovation in the space has helped to offset some of these challenges and is keeping costs from spiraling out of control completely. The rising cost of raw material has pushed innovations in the tracker space, from octagonal torque tubes, increasing rigidity to support large format modules, as well as standardized clamps for module mounting. Manufacturers are developing novel ways to reduce the cost of production and maximizing return on investment for trackers. Vendors are also increasing their research and development efforts to devise optimal storing strategies to mitigate against high winds, hail, and other weather-related challenges, all while trying to boost production. Tracker players are also offering proprietary software solutions that use sophisticated analytics, machine learning algorithms, which not only help with operation and maintenance, but they automatically store the trackers in case of inclement weather and modulate the rows to minimize the effects of shading and maximize tracking the sun. The technology has also evolved to handle sites with uneven terrain, high winds, rocky soil, etc. Now, with that as a background, let's get into the meat of the presentation and hear from our speakers from TerraSmart on how to select the right foundation for the site. We'll be hearing from Mike Faraone and Chris Lantz. And with that, I'll hand it over to you, Mike.
Sorry about that. Hi, my name is Mike Faraone. I'm Director of Engineering at TerraSmart. I have a background in geotechnical engineering, and I've been working for TerraSmart for 5 years. While working at TerraSmart, I've developed and designed both fixed tilt and tracker structures, both utilizing ground screws as the foundation. And during my time here, we've deployed almost 4 gigawatts of solar, which has us approaching almost 2 million ground screws installed.
Welcome and thank you to everyone for joining. My name is Chris Lantz and I'm the Business Unit Manager for the Fixed Tilt Division at TerraSmart. My background is in the construction industry with a focus in construction management. I have 11 years of experience in solar, coming from the RBI solar business where we've installed 6 gigawatts of driven post projects. 6 of those years were spent in estimating and pre-construction, with the last 5 in my current role as the Business Unit Manager for our Fixed Tilt Division.
Thanks, Chris. And so to start, we'll pull up a survey today. And we have a poll question on what you hope to learn after this webinar. The 4 options are A, a better understanding of cost implications of ground screws. Better understanding of the cost implication of ground screws. Hold on one second. Apologize there. A better understanding of cost implications of ground screws and driven piles in different terrains. Insight on what type of foundation is better for different terrains. Understanding scheduling timelines and risk of ground screws and driven piles. Guidance on the right type of foundation for a specific project. And it looks like we kind of have a 50-50 split coming in for cost implications. Let's see how they're changing here a little bit. It looks like a majority is interested in, so far, guidance on the right type of foundation for a specific project. And we'll bring the survey up later on to see what's of most interest later on. And so in the solar industry, the 2 most widely used foundations are ground screws and driven piles. TerraSmart is the first ground mount manufacturer to provide both foundation solutions. And today we'll be reviewing in detail both the foundations along with various site conditions that can be encountered along with cost implications for each type of foundation. So here we have a picture of a ground screw. It's comprised of a 3-inch diameter steel galvanized tube. They can be anywhere from 4 to 10 feet long, depending on, and the length of it really depends on the region that you'll be installing the ground screw, along with the soil conditions that you're encountering. The naming convention for ground screws are usually its length in millimeters. So an example of a widely used one that TerraSmart uses is a 2100 ground screw, which is roughly 7 feet long. The tip of the ground screw comes to a point, which is a forged chisel tip, and that helps penetrate hard, rocky soils. The threaded section that you can see on the bottom of the screw helps improve the tension capacity of the ground screw, which is we have to deal with a lot of uplift forces from wind in the solar industry. At the top of the ground screw, there's you'll see 3 set bolts. And that set bolt connection allows another post to vertically telescope within the ground screw to help capture a lot of undulations and deal with a lot of high slope terrain. These screws can be installed in a variety of conditions, and they excel well in rocky, hard, dense soil conditions where we first begin the installation process with pre-drilling a rock hole, and then that's followed by using specialized equipment pictured here with a hydraulic torque head to screw the ground screw into the ground. And rough production rates for these types of installs are roughly 175 screws per machine per day.
The most common foundation type for fixed tilt racking is a driven pile. Usually these are I-beams, W6x7, 6x8.5, or 6x9. What does that W6x9 mean? If you took that I-beam and laid it on your desk in the shape of an I, that height would be 6 inches. That is the 6, and that 9 is the weight per foot of that beam. So if you had a 1 foot section of it, it would weigh 9 pounds. So the difference between a 6x7 or 6x9 is that it's heavier, so it has more steel, so it's thicker, it's stronger. The typical length for a driven pile with the TerraSmart system is in the range of 12 to 16 feet. That's governed by a few variables, such as tilt, clearance, and your embedment depth. Piles are typically cut to length, fabricated, and then hot dip galvanized for corrosion protection and per UL 2703. Some companies like TerraSmart do have roll form shapes that they utilize for their foundations. We are able to make this shape in our own factory. It utilizes pre-galvanized coil steel that is fabricated and then formed into its shape. Our shape happens to be a C. These have lead time advantages due to the reduced number of processes required for the fabrication. The advantage of driven pile is they're readily available from multiple sources. It is a standard shape. It is able to be driven by fairly common pieces of equipment, same equipment that is found across the United States in the guardrail industry. Some of the machines that are owned by TerraSmart are able to drive foundation posts that are up to 24 feet in length. And the installation rate for our machines, we're on sites typically between 50 to 200 piles per day. It obviously varies per site, but we find an average about 125 piles installed per day. There are a few site conditions to look at before choosing the correct foundation choice. Flat terrain. We consider flat terrain anything less than a 15% slope. What is 15%? That's 8.5 degrees, but we also measure that as how far the ground lowers or raises over a length of space. So in general, our posts are on average 20 feet apart. So if the top of the post next to each other are greater or less than greater than a 3 foot difference in their heights, that's 15%. Flat terrain sites, they're able to be installed quickly. There's no need for additional adjustability in the racking. These sites are ideal, but typically they come at a premium. And our experience with these sites mainly are in the southern United States, Midwest, and in the Great Plains areas. The other sites are high slope sites. These are greater than 15% slope. Typically, your racking will require greater adjustability to accommodate this. The installation equipment must be able to maneuver on these more difficult sites. And a lot of our projects with this type of terrain we see are in the New England area and around the Appalachian Mountains. Another consideration is the subsurface. You could have anywhere from soft to medium dense soils all the way to hard dense soils. And these hard soils could include cobbles, boulders, and bedrocks. In these cobbles, boulders, and bedrocks at various depths, mixed with anywhere from soft to hard soils, can create a headache for your foundation installation. The geotech report can give you some idea on the subsurface conditions, but borings are not done at every foundation location, so it truly is impossible to know what is underground. TerraSmart is able to go beyond your geotech report with our pull tests and for both screws and piles, and get a better understanding of the site and to provide the best racking solution for every site.
Another site consideration is a regional consideration which has to do with frost heaves. So in northern regions where you have freezing temperatures, you can actually have within the soil itself, if there's water present, it can freeze and cause the soil to expand and heave up. And so on the left, we have a picture of it where you see a ground screw with roughly 6 inches sticking up above the ground. And then later on during the winter, we see that soil is heaved up and moved over that 6 inches. And the concern there is that when that soil freezes, that it can actually grab onto your foundation, and then as it's heaving, it's going to try and pull it up out of the ground. If you don't design to accommodate for those forces, you can end up damaging your racking structure, like this picture on the right where you see this waviness, and that's because you have certain piles that are being heaved up out of the ground over the winter. And the problem becomes that these piles don't go back to their original position. This heaving process continues, and this issue keeps becoming worse and worse, and can cause quite a bit of damage to the structure itself, the solar panels, or even the electrical equipment. And it can be quite costly to remediate. So it's important to understand that up front and to provide a design that can accommodate it. Another large problem for the pile installation is a term we call refusals, which is we define as the result of not being able to drive a pile to its full embedment depth. Technically, we define it as the pile cannot advance 12 inches over 30 seconds of trying to drive the pile, or it takes longer than 5 minutes to install. And the result of this is due to the subsurface soil conditions, which you could have either dense material, you could have cobbles, boulders, or some sort of bedrock that's impeding driving of the pile. And the problem becomes first is one, as you can see in that image in the middle, is that pile becomes damaged, or it could have an issue hitting its top of post tolerance, thus having impact downstream of the install of the racking or the tracker structure itself. When you start to run into a lot of these refusals, then you start to require additional time to the project, resources, and even additional cost. And so this is, probably the more risky aspect of a project if you start to run into having a high percentage of refusals on your project, delaying your project, causing quite a bit of headaches. And so to summarize which foundation is best, we've kind of gone through a couple different topics here, but if you have slope terrain greater than 15%, we recommend using ground screws, and that's because of the connection that it has to telescope its posts to varying heights to deal with any type of undulating terrain that you might encounter. If you have soils with a high refusal risk, we recommend ground screws due to the nature of being able to drill a pilot hole, which can go through any type of rocky, dense material, followed by the installed screw. If you have soft soils, then driven piles are a highly cost-effective option. If you have a site that has a high corrosion risk, both foundations are optimal because both are steel and galvanized. If you have frost heave issues, we recommend a ground screw. Because of that threaded portion, we can embed those beneath the frost depth line, and they're highly effective and tension resistant to resist that frost heave load. And if you have flat land with low slopes, at TerraSmart, we recommend a driven pile. And so at this point, we're going to bring back up the survey. Let's see. And if we look at the results of the survey, it looks like option B came in at the highest insights of what type of foundation is better for different terrains. And so kind of as we summarized here before, we find that the ground screw is optimal for those cases where they're able to, with those telescoping features, they're able to deal with a lot of undulations and has the adjustability to accommodate that high slope terrain. And from there, we're going to go into a case study to kind of look into the financial impact of these different types of foundations.
Thanks, Mike. Yeah, we at TerraSmart used our combined intelligence of being the industry leader in both driven post and screw foundations to create an industry first look at these different foundations along with a cost-benefit analysis. By the end of this case study, we want you to understand the different foundation challenges that each unique solar site can present, and take what we discuss here and in our white paper and apply it to your projects. So this case study is a side-by-side look at a 10 megawatt fixed tilt site where we compare driven piles and screws on both soft soils and on the site with a high refusals. And we're defining high as a 50% refusal rate for this case study. Here we have listed some of the cost and schedule assumptions that we used in our analysis for this case study. We have our price per foundation and along with our typical installation rates. On average, we see around 450 screws and 275 driven piles per megawatt. The price per foundation is higher for screws than it is on driven, and that's driven by the pre-drilling that is needed for every screw. We have listed 3 different types of remediation that TerraSmart team utilizes. So if a driven pile does hit a refusal, that $68 can change based on these 3 different options. The parameters and the type of refusal remediation option that is used really depends on how it compares to the parameters set by our engineering team. And these parameters that we use include our design embedment depth and a minimum embedment depth, which is based on the frost depth of the area, and then if it can pass a pull-out test and a lateral test. And if you would imagine a lateral test is if you stood next to the pile and pushed on it, that's kind of the like lateral load. First and least expensive is the cut and drill method. The post has driven past its minimum embedment depth. It's able to pass the load test, and the crew is just simply able to cut off the excess post, re-drill it, and move on to the next post. The next method is the move and redrive. We see this on sites with cobble the most. The post is driven, it hits a refusal that is either not at its minimum embedment or it does not pass the pull test. The installer can then move the post east or west, as governed by our engineering team, to a max distance of 1 to 2 feet, and then redrive the post. The final method is what we call drill and drive. Similar to the last option, you either did not meet your minimum embedment or you did not pass your load test. We primarily see this on sites with a lot of bedrock, where we have to bring a drill rig in, drill a 7 to 8 inch diameter hole, and drive the post in there, moving on to the next one. Typically with bedrock, we're doing that over and over and over. For this case study, this is the refusal remediation option we chose. With high refusal rates, you'll see that mainly with a drill and drive option. So we are choosing that as our assumption for this case study. First, let's take a look at the soft sites. Our comparison takes into account a few points. The first, and probably the most important, is the number of foundations. Based on our experience, we expect there to be roughly 2,750 driven piles versus 4,500 screws for this 10 megawatt site. We use those numbers along with the material cost of each and installation cost and time for each to come up with the data shown. As you can see, on a site with no refusal potential, the driven post option is considerably less expensive and has a shorter duration than a screw-based solution. The total cost difference is $207,000, or 2.1 cents per watt. And the cost per watt is used to help give an apples-to-apples comparison when you're comparing different sites or different options in the solar industry. It's calculated by taking the total dollars and dividing it by the DC size of your project. So in this example, the cost per watt of the screws is the 657,000 divided by 10 million, which is your number of watts for a 10 megawatt case study.
Yeah, Chris, and just something else to note when we talk about comparing a pile system versus a ground screw system is the quantity difference. You know, we typically see that for a system that requires a single pile, we usually will have 2 post locations, and that's, you know, that's due to the nature of how the wind loads resolved on a single pile versus a ground screw, where a pile is stronger in lateral capacity, and ground screws being a smaller section requires 2 screws to take up that same amount of wind load.
Thanks, Mike. Yeah, the takeaway from that was that for flatter sites with softer soils, driven piles are your economic choice. So now let's go and switch to the high refusal site. Here we're installing the same 4,500 screws and the 2,700 driven posts, but with 50% of the driven piles hitting a refusal. The cost and time to install the foundations on the driven pile project has increased dramatically. The duration has increased to 50 days, and the material and installation cost is now at 8.2 cents per watt. But as you see, we're still at that $657,000 to install these screws. So for sites with an anticipated high rate of refusal, screws are the best choice for both cost and schedule. So let's put all this data into one and show it. So this slide, it combines everything. The numbers outlined in green are for driven, and the numbers in blue are for screws. As you can see, screws, no matter the site conditions, their cost and schedule remains the same. You see a constant 26 days installation schedule and $657,000 cost. While in comparison, the driven post site goes from 4.5 cents a watt unit cost to an 8.2 cents per watt, along with an installation duration increase from 22 to 50 days. Now, your schedule may afford the increase in duration, but there are additional soft costs associated with an increase to your schedule of 24 days. Items such as rentals, utilities, and et cetera can erode the profitability of a project. You know, this is showing that the site and specifically the underground conditions can create variable cost and schedule for a driven pile foundation, but they stay constant for a screw foundation. Here's the summaries again. What this, driven piles cost 46% less to install and are 18% faster on soft sites, while ground screws cost 25% less and are 92% faster to install than piles on high refusal sites. I've had a few sites in recent years where refusals were known and the costs associated with them were either part of our contract or a unit price agreed to beforehand with our customers, but the schedule became the issue. And I've had more difficult conversations with customers on how to make up a 20-day schedule than a $200,000 change order for like refusals. And Mike, I'm sure you've had similar experiences with some of the screw customers too.
Yeah, we've been in plenty of competitive bid situations where the upfront cost of a pile is attractive versus a ground screw, but if the subsurface conditions aren't really understood, then there's a large risk that we like to try and communicate and try and alleviate from causing future headaches. We've had projects where we've had to be called in after the fact where they just weren't able to hit project timelines because they did not account for the subsurface conditions, and we had to step in and provide our foundation solution to make up that project schedule. So it's really just weighing that risk of versus that upfront cost to make the right decision for to develop a successful project. And so what we've kind of done here is, we've shown a particular case study, but then we've also developed what we call a break-even analysis. And so this is kind of we look at a general term of ranges of possibilities to start to understand where does it make sense to look at a pile versus a ground screw. And in this analysis, so we look at the same kind of numbers that Chris was presenting in terms of installation rates and cost, and we developed this chart here, which is on the bottom axis is our pile refusal, and on our vertical axis is our total installation cost. And so the light blue line represents the pile install cost, and so as you see that it increases as you're increasing your refusal percentages. That means you need more remediation on the site, thus your cost is going to increase. And then for the ground screw, because our installation process involves the pilot hole with the pre-drilling of the hole, followed by the install, that is a fixed cost regardless. And as we can see on a low percent refusal, that cost for a ground screw is much higher. But as soon as you get to this, what we call the break-even point of 29% for this case, that's when a pile cost and the ground screw cost is equal. And so from that point on, then a ground screw financially can start to make sense if you have refusal issues on a project. And then anything in between this dark blue line and this light blue line is kind of the risk of additional costs on the project if you don't really understand your refusal risk that you're dealing with. We can also look at the same analysis in regards to the pile refusal for the installation days. And so again, we have the pile refusal percentage on the bottom axis, and we have the install days on the vertical axis. Again, we can see that the light blue line for the pile install days is increasing with the increased number of install days because you have to have added drilling time, moving the piles around for additional pull tests like Chris was describing. And then for the ground screw, it is the same process regardless of the subsurface conditions of a pilot hole along with the install of the screw. And so for this case, we see that the break-even point is at roughly 7% refusals, 25 days to complete that 10 megawatt project. And then after that point, that schedule can blow up quite quickly, as we can see where, for the 50% refusal case, we were looking at almost additional 25 days. And that's where you have to start discussions of, if you don't understand this up front, bringing in extra machines, bringing extra equipment, bringing extra additional costs, and having discussions about liquidated damages, et cetera. So, the overall question is, we have these two great options, where do you start? Well, you could first start with just a pull test, having, a testing crew go out there and look at some of the drivability results for a pile. They go out there and test many locations, and you can see if they have run into any refusal issues while they're out there. You could follow that up or proceed that with a geotechnical report where they run a subsurface investigation where they either do borings or test pits, and they find out what type of materials down there. Are they detecting, rocks, cobbles, boulders, or is it soft soil? And they can help make a recommendation on foundation and possible refusal percentages. And then because each project has kind of different aspects, different racking structures, you can run we can help run a break-even analysis to determine, what refusal percentage is you need to start looking at a pile versus a ground screw. You should also be looking at identifying your budget and timeline goals for a project, because there might be, there are some subsurface uncertainties that you look at, and so you have to really weigh the risk of your project timeline and cost versus what you guys have already seen during your pull test and geotechnical report. And then basically you have to also understand the risk tolerance and who owns it. Is it the developer? Is it the owner? Is it the EPC? Is it the installer? That's could be a big headache if it's not understood up front. And then for us, when we talk about, where is a good point to start, for rough conversations, we always recommend if you're starting to see anywhere from 20 to 30% refusals, then a ground screw might be a more ideal option for that project site. And then that's when you maybe do some either additional testing, the pull testing or geotech reports to really understand your site to make sure you're not having a large risk. So in summary, we have two foundations that are available to us. The ground screw has less risk of refusals due to the nature of just being able to pre-drill a hole through any type of ground conditions. That results in the fewer risk of change orders and also less risk of schedule delays. Additionally, the product itself has a long lifespan because it's a galvanized steel product. For driven piles, there's a lower upfront material cost. Also, there's a lower upfront construction cost, which makes them ideal. It also has a long product lifespan because it is also a steel galvanized structural member. And It also doesn't require any specialized equipment, so it's widely available. So there's a lot of installers out there to put those into the ground. And so for TerraSmart, we not only offer both driven piles and ground screws, but we also have a diverse portfolio of other services that encompasses, racking, EBOS, and project optimization software. We use all these kinds of tools to help developers and EPCs determine the most cost-effective foundations. And, our mission has always been to make solar energy readily available anywhere and on any type of terrain. And, we've demonstrated this over the last 13 years with the installation of almost 19 gigawatts across 4,600 projects in the United States. And so that concludes our presentation for today. The case study that we've discussed here will also be available for download and afterwards. And then, hey, Sagar, we're happy to take any additional questions that may have come in during the presentation.
Perfect. Yeah, thank you so much, Mike and Chris. This was really interesting, especially the case study, which really highlights the advantages of screw piles for certain sites. All right, let's move to the Q&A portion of the webinar. As a reminder to the audience, you can continue submitting your questions through the module while we address some of the questions that came in. I think there was a few questions around the slides and the case study and the webinar, whether it'll be available right now or after the fact. Just as a reminder, we will follow up with an email to all the everybody who registered with a link to download the copy of the slides as well as the case study that was presented today. And there'll also be a link to the recorded session for today's webinar. All right, let me quickly scroll through some of the questions that came in with through the audience. I think this is an interesting one. One of the audience members wanted to know if you could provide guidance on the right foundation for environmentally sensitive sites.
Yeah, so it depends on what this. Oh, Chris, you want to go ahead? Or I can go ahead. So yeah, I think it really depends on the specific issue. I've seen for ground screws, there's been certain cases, it could be watershed issues. The fact that the ground screw itself is a smaller object, that typically is well received from different, AHJs, things like that are overseeing that environmental issue.
Yeah, we've seen some with the driven post. Yeah, I mean, it depends on what the environmental sensitive part is. I mean, if it's potentially corrosive, that could affect which foundation option you look at. But we can come up with a solution for almost anything. So.
Perfect. Awesome. Thank you for that. Another audience member wanted to understand, this might be a little technical, but how much higher wind speed does the ground screw handle over driven piles?
So there's a lot of, there is a lot of different options in terms of, for racking or trackers on how to answer that question. I would just say, in terms of the capacity, the tension capacity of the ground screw versus a pile, it's probably, a regular pull-out value for a pile might be, 8 to 9 to 10,000 pounds, where a ground screw can easily pull up to 18,000 pounds. And so I would say, in a high wind region, the ground screw will probably be a more cost-effective option.
Okay, awesome. Yeah, I agree. I think I agree with that. The other question that came in was, does TerraSmart direct hire construction labor locally, or do you have dedicated crews to do the installation? And there is a second part to this question, which is, how does galvanized, I'm not sure if they've completed the question here, but how does galvanized affect grounding and ground currents? I believe galvanized screws or piles is what they must be talking about.
So TerraSmart does both. We have subcontractors that install some of our racking, and we also do direct hire local labor. So we do set aside both of those. And as far as the galvanization affecting the grounding and the ground current, all of our products are subject to UL 2703, and I believe the galvanized racking on all of our products is used as a grounding path. So that listing pretty much dictates, that that's the grounding path from a safety standpoint.
Okay. Yep. Thank you for that. Let me just quickly scroll down and see if more questions came in. Yeah, there's another one that came in. Do you have any suggestions for posts in a terrain that has lots of bigger rocks?
Yeah, I'd say in those cases, TerraSmart, we would recommend a ground screw at that point. So again, that installation process is, like Chris showed, is more cost effective in that case study for hard, high refusal sites, and that's what a bigger rocks would present on that project.
Right. Yeah, I agree with that. Yeah, I think there was definitely displayed on the advantages of ground screws on sites that have high refusal rate and have big rocks. The other question I wanted to ask was, building more on that, at what refusal rate or percentage of refusals does it make more sense financially and schedule impact wise to switch to screws, I guess?
I think that's what Mike had looked at. Every site is different, but based on what we've looked at, that 20 to 30% rate of refusal, if you're anticipating that, then that's where you really need to really look at where, how do your economics look, and can you handle that additional risk with a driven post, or do you go with screws?
Okay. Perfect. Thank you. Yeah. Another audience member wants to understand about pricing from TerraSmart. How do you price installations? Is it fixed or time and material, or are there other components built into pricing?
Typically, our pricing is a fixed price.
Okay. Give me a second here. There's probably more questions that came in. Just scrolling down real quick. Here's another one. What is the methodology for determining frost heave design depth for ground screws, and do the IEs or independent engineers generally agree with the methodology?
Yeah, so there is, I guess there's kind of two different methods. One would be standard building code method, which usually turns out to be a very conservative value. And then the others are, depending on the region, that might be site-specific maps that give recommendations on frost depth. And we've seen those be more and more used on projects, and they've generally been agreed from IE reviews.
Perfect. I guess the presentation definitely went over this, but I'm just going to quickly ask this question again. What is the best practice to anticipate refusal rate prior to foundation selection?
I think
so it's going to be a combination.
Oh, go ahead, Mike.
Yeah, so that would be a combination of your subsurface investigation from your geotech report. I would say from estimating refusals from that, I'd probably recommend test pits. That's where you're able to dig out a large pit with an excavator and really start to understand a larger volume of soil, what that looks like. And then you can follow that up with a pull test investigation where they can drive test piles at multiple locations and understand, start to really build what that refusal percentage looks like.
Okay, perfect. Yeah. Here's an interesting question that came in, which talks about challenging sites. Is a sloping site more difficult because it's often associated with rocky soil and refusal, or the slope itself can be a direct problem?
So yeah, so I guess we see what we see now is, all the nice flat sites are going away. Land is starting to become more expensive, and so the worse the land, the cheaper it is, right? And so the difficulty, we do see both. Typically, if we have a large slopes, we have seen a lot more rocky conditions in those locations. But it becomes challenging from an equipment standpoint once you start to exceed, that we talked about the 15% threshold, but once you start exceeding, even 20%, 25%, then there's more additional challenges, safety challenges that you need to work with on sites like that.
I'd agree. From a driven post, we can install on greater than 15, but you're trying to mount modules and square and racking with variable slopes. It just becomes difficult with driven posts. So.
Got it. Yeah, I agree with the part. The flat sites are definitely being used up as there's more solar penetration that keeps happening. That was a great point. Another audience member wanted to understand if TerraSmart uses registered structural and professional engineers to certify the foundation designs, or is that typically handled by system owners?
No, so we handle design, and we're able to sign and seal in all 50 states.
Perfect.
So I would just follow up. We also are able to test, and we also have our own pull test crews as well, so we're able to collect that data and provide a design.
Okay. I think there's a thank you. I think the audience, I definitely should thank the audience. It's definitely become a very interactive session. There's a lot more questions that have come in. Just going over the list real quickly. What is used to mitigate corrosion for driven pile systems? I guess this is a question for driven pile versus ground screws. Is there increased galvanization, thickness, epoxy? What are some of the methods that are used to mitigate corrosion for driven piles? Or they might be applicable to screws as well.
Yeah, so for the driven piles system, we've used a few different options. Typically, it's determining first the design life needed for the site, and then how much that pile can basically corrode until it known as sacrificial steel, until it reaches that design life. Our most common and probably the most cost effective is just designing a bigger, thicker pile, giving it more of that sacrificial steel. In a few instances, we have had to add a epoxy coating to the underground sections, but that's typically not. That's very corrosive soils.
Mm-hmm. Perfect. Thank you for that answer. Here's another interesting question. How to manage an installation in rocky soils? And there's another one that asks about the pre-drill process. If you could describe a little bit in more detail what the pre-drill process is.
Sure. Yeah. So for a ground screw, managing a rocky site is, I guess we manage the rocky site because we're pre-drilling every single ground screw location, and in that process, depending on the type of soil and the type of rock we're encountering, it could be anywhere from a 3-inch to 4-inch hole, and we basically drill that out over the entire depth that the ground screw will be installed to, and then once that hole is drilled, then ground screw install machine follow along behind it and installs the ground screw.
Okay. Perfect. Awesome. Yeah, I think that pretty much wraps up a lot of the questions that come in. I believe some of them most of them have been answered. Yeah, perfect. Thank you, guys. Thank you to the entire team at TerraSmart for this presentation. Well, I guess there's another one that quickly came in. I'll go over a few more questions here real quick that just came in. Are there any differences if you're doing a fixed tilt versus a tracker project? Especially in that case study that you presented.
Yeah, you're going to see potentially a few differences, but it's still a function of number of foundations. So as long, I mean, that band, that 20 to 30% where you should consider, it's still around that area, but it just depends on the tracker system and number of piles, megawatt, and screws, your number of piles per like megawatt.
Okay, perfect. Awesome. Thank you. All right. Yeah, I guess with that, we'll wrap up today's webinar. I'd like to thank you both, Mike and Chris, for this amazing presentation and answering all of our audience questions. If there's a few questions that we may have missed out, we can follow up, after the fact via an email. And just as a reminder again to the audience members, there is going to be an email with a copy of the slides of today's presentation, as well as the case study that was presented, and a link to the recorded session for today's webinar. Thank you.